Welcome to Cybersecurity from Scratch, Technical Foundations, Episode 13.1, Secure Shell, or SSH, for red teams. This episode will cover the basics of how the SSH protocol works, and then go into some of the tactics that red teams will use to exploit SSH, and then finally we'll close out with some defensive SSH configurations. SSH is, at its core, an encrypted and authenticated channel for a remote command line interface to a system, plus there's some bonus features that we'll talk about too. Essentially, you can be sitting at one computer and then remotely connect to another computer over a command line and have full access to that system. SSH was developed as a replacement for Telnet. Believe it or not, we used to command boxes over plain text, and that was about as secure as you think it was. SSH works like this. A server will be running, and it's usually bound to port 22, which will accept connections and allow incoming commands. A client, to engage an SSH session, will connect to the server to start the transaction, and then the server will respond with its public key. The client will then decide whether or not to trust the public key. In a perfect world, the server and the client would have exchanged public keys in advance, and the public key would be part of a database. However, often what happens is the key is just visually inspected by a person, and as people aren't very good at remembering large strings of numbers, this doesn't usually work out too well, so oftentimes it's just a pro forma acceptance of the public key. The client then checks to make sure that the server actually has the private key corresponding to this public key. And the way this works is the client will encrypt something using the public key and make sure that the server is able to decrypt it. Now, if the private key isn't held by the server won't be able to decrypt it, and the client knows that there's some kind of shenanigans going on. The client will now send its public key to the server. The server will then examine the public key and decide if it wants to trust the client. It checks to see that if the public key has been registered with a particular user and if that user is authorized to connect. If the server decides that it likes the client's public key, it will respond with an encrypted message that only the client could decrypt if they had the corresponding private key, thus proving that they have the private key and they are who they say they are. From here, the client and the server will agree upon a shared key which will be used for this particular session. Since public key cryptography is a little too slow to be using for continuous messaging, the symmetric key will make sure that it stays protected. And then from here, commanding begins. The client will send instructions to the server will send responses, and the session is open. Alternatively, the server can be set up to trust username and password instead of a public key. This way, when the server and the client exchange public keys, the server won't see if that public key is associated with an authorized user. Instead, the server will get the session going and then check to see that the username and password, once it's transmitted safely in a secure channel, match a username and password in its own database. This isn't quite as secure because there are ways of stealing this over the wire, which we'll talk about in a few charts. If you're setting up SSH on a client for the first time, you might need to generate SSH keys. To do this, you can use the Ssh Keygen command, just as shown on the screen. Now note I'm showing the command using the RSA algorithm, which is getting a little close to its end of life, but it's still secure for now. You can also use the -f and then file name argument to supply a directory, which otherwise, if you don't use that, the keys will end up in the default directory for the user that you're logged in as. But using the -f flag, you can create a second set of keys if you want to not use your main key for some reason. Using SSH is really simple. You simply say SSH username at the host that you're trying to get to, and the system will automatically load the SSH key that goes along with your username and supply it as part of the session. There's just no extra action required. Now, if you have generated a different private key to use, you can use the -i flag with this SSH command to use a non-standard key. And then that way you can sort of have multiple keys going on in your system at the same time without just relying on the defaults. Now let's talk about what red teams can do with SSH. Once a red team is inside a system, one of the first things that they check for is the private and public key for a particular account that they've compromised. These keys are by default stored under .ssh/idrsa, and then for the public key, .ssh/idrsa.pub. They'll also look around for other keys that might be accessible, since of course keys might not always be in that default location. The keys might be protected with a passphrase, but there are tools for that. Once the attacker has the private key, they're able to impersonate that user at will. Each user has an authorized key file, which lists the public keys that are authorized to log in to that account. Essentially, this is a list of public keys that the server will trust to identify who is who. So say, for example, that an attacker compromises Gary's user account. While logged in, they can add their own public key to Gary's authorized keys file, and then they can present their own keys later on, and the server will think that they're Gary. This works with root as well. Root has its own .ssh directory and its own authorized key file, and so by adding the public key there, the attacker can get root access to a system at will and establish persistence that way. If the attacker is able to control how a victim is routing their session, they can launch a man-in-the-middle attack. This can be done by corrupting DNS entries so that the user tries to log into their server instead of the real server. There's all sorts of ways they can do this. Either way, the general attack is that the attacker will intercept any incoming connections and then compromise them by basically decrypting all the information and then forwarding it on to the actual server. Now, if the victim is using a username and password, the username and password is decrypted, and now the attacker has it. However, if private keys and public keys are being used to authenticate, then all the attacker can do is pass messages back and forth. But because the attacker never has the private key, there's no way of impersonating the client. SSH can be used for port forwarding, which can be used for malicious purposes or perfectly valid use cases. It all sort of depends on what's happening. First, we're going to look at a simple local port forward. Essentially what's happening is the attacker is setting a local port, in this case 8080, and then routing it through a compromised host, 10.10.10.10, and then routing that to port 80 on 10.1.1.1. So what's happening is they can then, on their local system, fire up any tools that they want, connect them to port 8080, and then use that to route through to port 80 on 10.1.1.1, which is really useful if 10.1.1.1 is behind a DNS or otherwise not routable. Essentially, the attacker can then tunnel into a segment of the network that they couldn't otherwise get to. Now, the command to do this, the syntax is a little bit arcane, so I have it up on the screen, but essentially you tell SSH to bind a local port, in this case 8080, while connecting to ultimately system 10.1.1.1 port 80, routing that through the compromised user account Gary at system 10.10.10.10. It's a little arcane. I'm going to show an example of this working. Here we're going to start an SSH tunnel and show how it works. What I'm going to do is start binding a local port 8080 and have that route to this remote IP address, which is a web server that I own, and port 80, which is the HTTP port. But I'm going to do the tunnel through another system on my local area network here. So essentially what will happen is when my browser connects to the website, it'll do so through this tunnel here without ever directly routing outwards. Now we can see that I have a normal SSH session here, which is command line access to that system. But then if I go over to my browser, I can route to the website. So you can see how this is useful for either funneling traffic through a network through a common point, or from a red team perspective, if a system has SSH access, you can tunnel traffic to other systems on that network via the compromised host. We have the option of doing a remote port forward as well, which is sort of the opposite of the local port forward that we just did. In this case, we're SSHing to another system and telling it to open a port locally on the target system, which will then redirect back through the SSH session to a port on our local system. So say, for example, that we're trying to get a socket opened on port 80 on that target system and have it direct back to 8080 on our current system, the attacking system. Then we would use the command SSH and then have the -N and -R flags, give it the port 80 designation saying that we want that to open on the remote host, and then 127.0.0.1 8080 saying localhost port 8080, and then the credentials that we want to use to log into the target VM. Now, this is really useful for a red team engagement if, say, for example, the attacker is able to compromise the routing for a particular service. They can route traffic which would be going to a trusted internal host out to the attacking VM. Perhaps the most powerful tool in the SSH port forwarding toolbox is the dynamic port forward. Here, someone can open a port dynamically and have it route to any arbitrary remote destination. So for example, we'll use the SSH-D flag here and specify binding a port on 1337 and localhost, and have it route through the Gary user account on 10.10.10.10. But in this case, instead of saying the traffic has to be routed to a particular host and port, the traffic will be routed anywhere. So essentially the traffic could go from the target 10.10.10 system to any system that system can touch. So if it's inside a firewall, if it's behind any sort of protective layer, then the traffic from the attacker will be able to route through to it. And this is a very powerful tool for sort of, after having gained a foothold, spreading out and enumerating the rest of a network. Once the dynamic port forward is established, the attacker can use proxy chains to route any number of tools through that proxy to whatever destination they're targeting. What proxy chains essentially does is wraps the target program in a library that routes, instead of the normal traffic to the normal port, all the communication through the proxy as if it's originating from the point of that proxy. So for example, if someone is running Nmap through proxy chains, then the target network, which is normally behind whatever protective layer is available, will go right through 10.10.10.10 and map, as if the program was being run locally. Now, there's one important caveat in that proxy chains doesn't really work well with everything. It's a lot slower. And so for some things like web enumeration that require a fast connection and many connections, you really don't get very good performance out of proxy chains. And so in that case, a local port forward to the specific service that's being enumerated is a much more effective technique. Chisel is an alternative way of establishing the same port forwards that SSH does. It's a standalone client and doesn't require the server to be running SSH, and it doesn't require bundling with the username and password or private key authentication in use by that server. However, the downside is that the binaries that ship for Chisel out of the box are very easily grabbed by Windows Defender. So if the red team is engaging on Linux that doesn't have antivirus, that's a good option. But for Windows, you have to do something a little bit more clever, like trying to disguise the binary in some way to get around the antivirus. However, it's a really good tool in the toolbox. Let's say, for example, that someone has access to 10.1.1.1 and they can get code execution on that system somehow. What they can do is use Chisel to further enumerate services on that system. Say, for example, there's a MySQL database running which isn't externally routable. It's protected by a firewall or something. For some reason, for whatever reason, they can only route to that port from inside the target VM. No problem. So what the attacker can do is set up a Chisel server where they bind to a local port, say port 8000, and give it this reverse flag saying that it will accept incoming connections. And then from inside the victim VM, if they have the Chisel binary placed, they can instruct the Chisel program to act as a client in reaching out to the attacker IP address in port 8000, and then it will say that they want to establish a connection from remote port 3306 on the target VM and port 3306 on the attacker VM. So essentially what this looks like is the diagram on the right side of the screen here, where a port 3306 is opened on the attacking VM, which the attacker can route to, connected through the reverse Chisel program, which is bound on port 8000, and then connecting into the port 3306 on the target VM. Now, the cool thing is the attacker can then use something like MySQL to connect locally to 3306, and that will be routed through the tunnel to the MySQL server on the target system. As blue teamers, there are a number of things that we can do to help make our SSH endpoints a little more secure. The cardinal rule is to keep keys secure. Users should only be able to read their own keys. Now, when you fire up an SSH client, it'll check to make sure the permissions are okay for a key and that a user doesn't have a key that's being used too openly. However, that still is an opportunity for someone to create a copy of the key or for a sysadmin to, leave backups unprotected or things like that. There's all sorts of ways of accidentally leaking keys or just integrating into a workflow some key management that's not safe. We also want to restrict login rights and make sure that only users who have a real justifiable business case for logging in over SSH can do so. The SSH daemon configurations can be updated in a secure way, and I'll talk about that on the next chart. And then finally, we can block Chisel. The blue team has better tools for doing port forwarding, so really a Chisel is a good indication that somebody is trying to do something malicious. Now, Windows Defender does recognize Chisel by default, which is awesome, but make sure that whatever AV solution you're using is set up in a way that it's going to recognize the standard binaries at the very least. For the SSH daemon configuration, allow users, allow groups, and on the other side, deny users and deny groups are very useful for permitting and denying access. Use those controls judiciously. Also, the permit root login flag can be used to guard the root account against SSH login if that's something that fits with the business case. Commands can be specifically restricted, including forwards, so just because someone needs to log in doesn't mean they need to be able to port forward. And if, for example, they have a low-level permission and can't write to the SSH configuration, they might be able to get into the system via SSH but not be able to port forward, and this effectively helps limit the ability of an attacker to pivot through a system. Obviously, there's other tools they can use, but anything that slows people down is a good thing. You can also establish a max retries. If, for example, someone has a number of keys that they're trying or a username and password combination they're trying, limiting the number of retries can lock down accounts and prevent them from brute forcing the system. In episode 13.2, we're going to be covering evil file transfers. Say, for example, you're a pen tester and you have a web shell on a system. How on earth do you get a file over to that system? There's all sorts of cases like that where it's a little bit challenging to move files around, and we're going to be covering what tools pen testers, red teamers will be using to introduce files into a target system. And of course, we'll be talking from the blue team side of things at what we can do to frustrate these attempts.